Hello, it's Keith from Kinvert, and I want to go over a slightly more difficult example of an absolute value inequality. What happens if there's a negative inside the absolute value, and what happens if it's compared to a negative value? Because if it's a positive value, we know to kind of swap signs, set the other to negative. I'll have that in another example. So let's do an example with a negative in here. Negative 2x plus 3 is greater than or equal to negative 13. Let's try that. I don't know how it's going to fall in here. You know what? I'll do a negative 7 so it's more likely to fall near the origin so that it's easier to draw. Okay, so let's just begin. So again, I'm trying this. I don't have this memorized how to do it. Let's see. So what I think is going to happen is we're going to have negative 2x plus 3. Wait a minute. This is impossible. There would be no solution. I can already know that, right? Because an absolute value cannot be greater than negative 7. Wait, no, it would be greater than, it would almost always be greater than negative 7, right? Duh. Because an absolute value is always positive, and this is negative, so it's always going to be greater. Let's just see how this works out. So we've got our first one, greater than or equal to negative 7. And then would you need to swap the sign? I'm going to try it. And then we'll see if I'm right or wrong. Negative 2x plus 3 is less than or equal to 7? Question mark? I have no clue, so let's try it out. All right, so first we're going to cancel away. One of the things I want you to see is that there are ways to figure things out in a test, even if you don't know the answer. All right, so we're going to take away the constant. Okay, this is a step that we all know, right? And what do we get? Negative 2x is greater than or equal to, we think, negative, negative 7 minus that, negative 10. Hope I'm right. And then negative 2x is less than or equal to 4. Okay, we'll see if it works. We're going to isolate away the coefficients, divide everything by negative 2, negative 2, negative 2, and let's see how this one works out. Okay, this just becomes x is greater than or equal to 5, positive because it's negative, divided by negative. Ooh, wait. Okay, this would need to get swapped because I'm dividing by a negative here. All right, glad I caught that. Boom, boom, boom. Okay, so we swapped this. I've been doing light blue for this. I don't know why. Okay, back to orange. Negative 2, so we've got x, and then we swap the sign, greater than or equal to, and then we have negative 2. Did this work? I don't know. We'll find out. All right, so greater than negative 2, so we've got a negative 2. Less than negative 5, it's going to be in here, according to the way that I did it. We'll find out if I'm right, because we can compare to the original equation. Let's do one at, these should just pretty much always work. It's these ones that kind of matter, so we'll try negative 1. Negative 2 times negative 1 is going to be just 2, plus 3 is 5. That is greater than 7. Okay, good. And then we'll go to 4. We'll see, but all of these are going to be greater than negative 7, right? In theory, in my mind, any single value, even a 0 for x, no matter what x is, it should still be greater than negative 7 because an absolute value is always greater than this. So, this one checks out, but this is saying that x needs to be greater than negative 2. Okay, so let's try negative 3. This should theoretically fail, or that means I did it wrong, right? So let's see here. We've got negative 2. If we multiply that by negative 3, we have positive 6 plus 3 is 9. 9 is greater than or equal to 7. So see, this is a solution that works right here that I don't have in my solution set. So I think that this is my guess, okay? Because I haven't seen this like in a textbook. I haven't probably done absolute values in forever, right? When would you use them in engineering? I'm not sure, but I mean, really, any solution for x should be greater than a negative. It should always be greater than a negative. It should probably never even be equal to. It should only be greater than a negative. All right, so I'll make another video. This one's kind of inconclusive, right? So I apologize. I don't really know how to officially show that. Again, I'm not a mathematician. I'm an engineer. But yeah, to me, all values of x, all of them, no matter what it is, negative infinity, positive infinity, if you take an absolute value, it changes whatever it is. If it's negative, it changes it to positive. And any positive number, 0.0001, is going to be greater than -7, right? So it should just be all values, all real values at least, of x should be greater than -7 because it's an absolute value. So anyway, this is part of our online course for pre-calculus and algebra. Hope you found this helpful. This wasn't as kind of straightforward as the others. The next one that I'm going to make is going to be more straightforward, where we just have the negative in here and then this is a positive number. So that's what we'll be trying next. I'll see you in the next one. Bye-bye.